ball is moving as a conical pendulum in a 2.0 radius circle. What is the angle to the vertical? The ball has a period of 4.0 seconds.
Hi. So basically what you want to start off by doing is just like every other problem we've ever done is start by creating a design of what the problem is like. And for those who do not know what a conical pendulum is it's basically a pendulum that is attached to a string that when it rotates around a circle creates sort of a cone effect. Anyway, so we have our ball there and we're solving for this angle up here that's being held by the string. And so we are given where the radius is 2 meters, the time is 4 seconds, and the acceleration on the y is 0. And that's only because it's a horizontal circle and the ball is moving up or down. And what we're solving for is velocity and the acceleration of the ball going around the circle. And so then we draw our free body diagram where of the ball gravity is pulling it down and the force of tension of the string pulling it up with our x and y components and our angle up there, which is the same angle that's right there. And so before we can start to work on the equations, the net force equations for the free body diagram, we have to find what velocity and acceleration are equal to by using these equations. Velocity is equal to 2 pi r, the circumference of the circle, over time, that's a period basically, and acceleration, which is v squared over r. And so we substitute what our givens are. So velocity is equal to 2 pi r times 2 over the time, which is 4. And so velocity will be equal to 4 pi over 4, or equal to pi. And now, I wish I could write pi, but physics. So velocity is equal to 3.14 meters per second. And now we use this information that we just found out in here. Plug that in. Acceleration is equal to 3.14 squared over the radius, which is 2. So acceleration is equal to 4.93 meters per second squared. Now that we have all that we need to solve for the angle, we can then plug it into our net force equation, which is the force of tension times the cosine of theta, which comes from the y component of tension, minus the force of gravity is equal to mass times acceleration of y. And that comes from that minus that. And so, now that we know that acceleration of y is equal to 0, we'll plug that in. So f of t times cosine of theta, just show that that's 0, is equal to, bring that over, force of gravity. And so we solve for force of tension, which is equal to force of gravity over cosine of theta. Now we can use this in our x component equation.
And so, now we set up our x component. And from our free body diagram, we can infer that it is force of tension of the x component is equal to max. And force of tension is equal to force of tension times sine of theta, which is equal to max. And from earlier, we found that the force of tension is equal to the force of gravity divided by cosine of theta. and we plug that into force of tension in the x component equation to get force of gravity divided by cosine of theta times sine of theta is equal to mass times acceleration. Now we know that the force of gravity is equal to mass times gravity times sine of theta divided by cosine of theta, which is equal to tangent of theta, is equal to mass times the acceleration, which we found earlier to be 4.93 meters per second squared. And we can see that there's mass on each side, so those cancel out to reduce to gravity, which is 9.8 times tangent of theta, which is equal to 4.93. And so we divide 4.93 divided by 9.8 to be tangent of theta is equal to 0.50355. And so theta is equal to 26.7 degrees.